Now for the designing of steel column, steel beam, truss members, girders, we need some formulas from some code guidelines that are after long years experience of years. Okay, so the specifications are given by some codes. So what codes give the specification for the steel design, we will see. The adequacy of a structural member is determined by a set of design rules called specifications. These include formulas that guide the designer in checking strength, stiffness, proportions, and other criteria that may govern the acceptability of the member. For the design of member, we need these specifications. There are a variety of specifications that have been developed for both materials and for structures. Each is based on years of research and experience gained through actual structural usage. So here are following codes for the steel construction and steel designing. AISC 360 that used for the designing of steel members, that is American Institute of Steel Construction. AISI, American Iron and Steel Institute, for database like different type of steel sections, angle section, channel section database is given. AWS, American Welding Society. ASHTO, American Association of State Highway and Transportation Officials. AREA, American Railway Engineering Association. ASTM, American Society for Testing and Materials. ASC, American Society of Civil Engineers. In these standards, you already know some of these names, so remaining I have covered. Types of load. Dead load. It almost retain its magnitude and point of application throughout the life of a structure, and it is denoted by D. This load is usually the self weight of the structure, not only this member but all other members resting on it. Okay, for example, a column. In column, the above load which is resting on the column, that will be act as a dead load, like slab load, beam load. All the load resting on the column that will be act as dead load will be denoted as D. This is estimated by multiplying the volume of member with the standard density of the material of a construction site. Means you will multiply the volume of the member with the density, you will get the total weight of that material. This load constitute a bigger part of the total load on the structure, means dead load have a major contribution to the structure. Live load. The load due to persons occupying the structure and their belongings denoted by L. Its magnitude and point of application changes with time. Like the students in the classroom for the designing of a school, maybe one day students come 40, another day 35, another day 30, so their value will change. The student come and go, so its magnitude and point of application changes with time. In case of bridges, live load consists of weight of vehicles moving over the bridge. Means on the bridges, the vehicle load that will be used as live load. Typical values of common occupancy type are given in the next slide. Here is a table. For a private apartment, schools, classroom, you can use live load 200 kg per meter square. Similarly, different, for example, library stack rooms 750 kg per meter square. For heavy machinery 1200 kg per meter square. Self load. It is the subtype of dead load. This is the type of dead load which is due to self weight of the member to be designed. For design, a reasonable value of a self load depending upon the past experience is assumed in the start, which is then compared with the actual self weight at the design. For example, for the calculation at the start, we assume some self weight, and after designing, when we get the actual section, we compare that what will be the weight of actual section. If there is a no difference with the assumed and the result, then there will be no revision. And if there is a difference in the previously assumed self weight and design self weight, then we have to revise the section with the new self weight. Corrections in the design are made if necessary, that I have explained. Other types of loads are wind load, earthquake load, water and earth retaining loads, and temperature loads, etc. Imposed / superimposed load. This term is used for all external loads, leaving the self-weight acting on the member to be designed. Okay, this terminology is used. Except the self-weight, all other loads are superimposed load. This includes snow load, wind load, earthquake load. Part of the dead load may also act as imposed load. Service loads. The simple definition of service loads: all the loads which act on the building throughout its life without any factor that are called service loads. Means the maximum intensity of load expected during the life of the structure depending upon a certain probability of occurrence is called service load. Here, no additional factor of safety or overload factor is included in the service load. Means in service load without any factor, loads without any factor. And factor loads means loads with factors. Service loads increased by some factor of safety, like when there is a dead and live load, you will multiply the factor 1.2 into dead plus 1.6 live, that will be factor loads. And if there is a only dead load, so then the factor will be 1.4 dead, that is given by code, that are called factor loads. Mechanism of load transfer. The basic mechanism here for in a building, okay, the load will be transferred from roof surface to roof slab, then from slab to beams to columns to foundation to subsoil, and subsoil will transfer and spread to the ground. Okay, so that's the load transfer mechanism. You can read, that is so easy, so that's why I am skipping the read, because I have explained here. Means load transfer mechanism. Again, this is the same, like for the beams, columns are acting like supports. For the slab, beams will be acting as a support. For the beams, columns will be acting as a support. For columns, foundation will be acting as a support. So that's the explanation here. And for the foundation, subsoil will be act as a support. Underneath soil act as a support. These steel lectures are taken from Steel Structures book by Dr. Zahid Ahmed Siddiqui and by Dr. Ashraf. And special thanks to Dr. Zahid Ahmed Siddiqui for this book, for this nice book. So thanks for listening. Thanks for your patience. Have a nice day.